Good morning, everybody. Today I'm talking about how we are moving to an autonomous driving core network. Before we move in more detail, I would like to share what we learned about the challenges that the telco system that is facing. So the first one is the first one is that we realize in a lot of our customers, carriers network, during past 10 years, the speed of the OPEX increase, revenue increase. The speed of revenue increase never exceeds the increase of the OPEX, which we call as a structural challenge, structural problem of the telco system, which means how to efficiently reduce the OPEX is going to be a big challenge in this years. Once we compare the network operational efficiency between the carrier network to the OTT, we found out that maintaining 10,000 equipment, OTT need 3 engineers, while the carriers in a lot of network, they need 384 engineers to maintain same amount of equipment. What we found out is that maintaining the carrier network relies more on human skills instead of the machine itself. On the other hand, let's see, the network complexity increased year by year. And we also see that about 70% of network failure actually are caused by manual operation, caused by human. And 5G is coming. We are in the 5G era, and it is expected that there are going to be globally 100 billion new devices going to be connected to the system. What we see is that the network complexity is going to exceed the human capabilities very soon. If you are familiar with Huawei, you probably heard about the OIP strategy or cloud strategy or intelligent strategy. 10 years ago, we talked a lot about the OIP. OIP helps a lot and changes a lot for the network, especially to help to reduce the cost of the network. 70 years ago, we talked about cloud strategy. That is targeting to build up a data center-based network system to make the whole of the system more flexible, more manageable, more advanced technology involved. And last year, start from last year, we talked about Softcom AI. We introduced the artificial intelligence technologies into the telco system. We are targeting to build a fully autonomous driving telco system. Then why we are talking about core network here? Taking an example of the VoLTE service. When we need to build up a VoLTE-capable service, a network, there are going to be about 40 different kind of network elements involved, more than over 60 different kind of interface connected. And we need to take care of about 30,000 different KPIs to identify the problem, the troubles, to improve the user's experience. The complexity, the network is very complex. And it's getting harder, more and more difficult to improve the user's experience in this situation. And now, new technology is coming, the 5G, which makes the network more complex. Then the question is how we are going to, how we can achieve, realize an autonomous core network, autonomous driving core network. Basically, it can be divided or can be considered into 3 key factors or 3 key layers. The one is intelligent orchestration. The purpose to have the intelligent orchestration is to have a full automatic an intelligence controller and orchestrator to manage the whole of the system from the service to network, from the software or application to the resources. The second layer is the Agile network, Agile core, to make the whole of the system programmable and orchestratable. So to be able to be capable to fulfill the differentiated service requirements and quality of service from different verticals, different markets requests. The third one is the pipeline. Pipeline automation, or we say the workflow automation. So let's start from the orchestration, and we see the engine of the orchestration, intelligent orchestration. It can be considered as three engines, actually. The intent engine helps to translate the service policy descriptions into the network configurations. And also, it helps to instantiate the network functionalities based upon the service request. The scheduling engine, it is capable to be aware of the network resource usage situation, the performance of the individual hardware components. And it also works together with the SDN controllers to realize a cross-domain and SDN synergy, to make whole of the network configuration and synergy more easily and more flexible. Then the analytics and intelligence engine, in which the AI or machine learning exists. By using the AI and machine learning, the problem, the trouble can be figured out and identified more easily and quickly. So I put some numbers here right now, what we have already achieved, that about 80% of the service scenarios can be translated into the network configuration automatically. With the awareness of the hardware performance and usage, about 20% of the resource can be reduced based on the automatic optimization. And now, about 85% of the anomalies can be detected before it's spreading into the whole of system to make a big failure. Then we touch a little bit about the technical detail, how the AI and machine learning works in the engine. So here we can see, based upon the data lake platform with the machine learning engine there, we put all of the accumulated history data into the system. It calculates, find out generate the pattern or the model, in which way it leads to success and which way it leads to the failure. And then, based upon that module, we pull out the real-time, runtime data and match the data and parameters with the model, with the pattern. And then we find out, okay, this is going to be a problem. Potentially, it's going to lead to failure. So the model here specifically output is a dynamic threshold curve. And there is a range, okay, this is the normal and this is the problem. Once we get all the real-time data and match together, once it go out of the scope of the curve, of the dynamic threat, it potentially be a problem. That's what we call as anomaly. It doesn't mean it's a failure. But a lot of anomaly exists, and with the machine learning, we can find out, okay, this is potentially the problem. So at this point, because the engine keep running and running day by day and moment by moment, the accuracy is improving by itself. So till now, the 85% of accuracy come from 40% from very beginning, and the accuracy is improving better and better as long as the data, more and more data are input into the system. And once they got a problem, there is the decision tree. is knowledge-based. Where the knowledge is, where the knowledges are from, they are from the engineers. Their knowledge based upon their experience during their maintaining the network during the last 30 years. So they know what kind of situation once it happens and what is the failure could be, and with which the root cause can be identified, can be verified very easily. And at this point, with the help of the decision tree, the fault demarcation speed at this point can reach the minutes level instead of hours. Then the second one is the agile core. To make the whole system autonomous, driving capable, the network itself needs to be polished, needs to be enhanced, to be able to be programmable and orchestratable. When we talk about the programmable, we actually more focus on the user plane. When we talk about the 5G network, there are control plane and user plane. The user plane needs to be programmable and be controllable by the control plane. The user plane, programmable user plane, needs to separate all the different functionalities as a blocks, as a small features. Let's say the data for packet forwarding, the encapsulation, the encryption, the traffic optimization, different kind of functionality need to be separated and it can be assembled according to the requirements of the features and requirements of the quality of services. And on the control plane, all the functions need to be decomposed, separated, and reassembled once again, based on the need of the different verticals and service requests. That we call as network slicing. The technology behind to make the system programmable and orchestratable is the microservice capability. When we talk about microservice, we are not talking about how small granularity it is. We are talking about how to make each block, each microservice be capable to be managed as a whole life cycle perspective. So each block needs to be considered and designed carefully to be able to develop, tested, upgraded, terminated by itself, which means every small single microservice component can be managed into the system, can be upgraded into the system instead of as a whole bunch of software components. And then the pipeline automation, all the orchestration, agile core are about features and capabilities. To be able to make the whole of the system automatically, there need to be automation of the workload, from the system design to the deployment to the upgrade to the testing. Those type of stuff need to be done automatically. So here we can see with the automatic the planning, within 30 minutes, the quotation can be translated into the network configuration. The installation, actually in a real network, we achieved to start up a whole of the system to enable the system and features within 30 hours. We using traditional way, it takes weeks, months. With the automation of the workflow, it takes hours only. With the testing, acceptance testing, 85% of the test use cases has already been developed and can be tested by machine automatically, which means only about 50 use cases, 50 test cases need to be handled and performed by engineer. In this way, a lot of workload can be saved, and from the launch of the software releases from the vendor, to be able to be to upgrade into the system can be more can be quicker, much quicker. And A/B upgrading, A/B testing, which allows to have different versions of the software existing to the system. Instead of to upgrade the whole of the software, we only need to upgrade our components and test it and try. You have a friend user to see whether it works or not, to terminate or to use it based upon the need. And then upgrade the whole of the system step by step. So the engineers, they don't have to work in midnight. A lot of engineers have to work in the midnight to have the whole of the system upgraded. But with the A/B upgrading, actually this kind of work can be done on daily, during the daytime. So here's the real case, how it works with our partner, with our customer. Actually, AI can work a lot of directions. And here we found out in 4 use cases, it works very well. Automatic planning, to have the translation from the service request to the network configuration. And since the engine has the capability to optimize the hardware resource usage by itself, automatic optimization, about 20 to 30% of the hardware can be, the efficiency can be improved. Then the automatic failure detection, since the anomaly can be detected very quickly before it spread into the system. So about 90% of failure can be predicted before it happens and can be managed. Automatic demarcation, for demarcation in minutes instead of doing a lot of actual human work. Automatic healing, since the failure can be predicted, can be detected by the system. Now about 80% of failure can be recovered by the system itself automatically in 2 minutes. Still, it's a long way to go to realize a fully autonomous driving network. Taking the driverless car as a reference, the level or the stage can be divided into 5 phases. Start from assistance anomaly, which is rule-based. So we know what the rule is. We put it as the commands, as the batch commands, and then it runs. That is a tool-based or rule-based system. To eventually to have the fully autonomous network, which we want it to be self-evolving capable. It takes 5 steps. By adding the AI-powered platform and engine and algorithm there, we are running on the 3rd level. And we are working hard to make the system be capable to have the self-optimization capabilities and to be higher accuracy on the failure detection, to have the predictive maintenance capability to run into the level 4. So it takes time, but we are on the right path, right way, and we hope we are working together with our partners and whole of the industry moving forward. So last page actually is a takeaway. As a summary, what I talked about the aiming, I talked about the structural problem or structural challenges. And structural challenges always need a systematic innovation. That's what we are targeting to have the fully autonomous driving network, to have a fully autonomous driving telco system. I talked about the 3 major factors: to have the intelligence orchestration, to have the agile core, programmable and orchestratable. I talked about the pipeline automation, to have the whole of the deployment upgradable, system upgrade to be more automatic. Then the final One, we are still on the way to the to reach to establish the full autonomous network. So 5 steps. We're on the 3rd step. We are moving forward. Thank you very much.
Thank you, David. David, hold on. We have a time for a question. Thank you for staying on time. Yep. So, you want to take a question, David?
Yep, sure. Go ahead.
Actually, do we have a microphone somewhere?
Please go. Can I? So thank you very much. Just wondering about the data set you have been using. What is the time frame of data? I'm assuming this is supervised learning. How long did you take the data to do a supervised learning for one incident?
Yeah, that's a good question. So actually, the more data we get from the system, the more accuracy it can achieve from the machine learning perspective. Normally, to achieve acceptable accuracy of the machine learning, normally we need about 1 month's data.
1 month?
History data, right.
1 month is
about, right.
That's it? That's pretty good. Okay.
Yeah, normally, right.
Yeah, because we do actually anomaly detection also, but we need really 6 months of data. That's why I was wondering. So 1 month is pretty good. Thank you.
Yeah. But that is acceptable result. To have a higher accuracy, apparently, more data will be appreciated. Yes, yeah. That's a good question. Thank you for asking.
Any other questions from the audience? Because we would move to a couple of final questions just very quickly. Is there any other questions in the audience?
Okay, we had a couple questions earlier, and now we...
Just can we just
If you
quickly?
can put those up.
Do we have a?
So there's a quick question for Cliff. It looks like. Oh, how is OpEx being saved if you look at...
Here comes a mic.
Yeah, microphone's coming.
So I think the question is, how is AI and ML going to help with OpEx savings? And from the discussions we've had, it's all about removing the burden from the engineering and letting the machine take care of that. So operational time of individuals is going to be one of the big savings that we look towards. And we saw it in the presentations from the people that followed me about the time reduction in troubleshooting and all the things that engineers need to do, not to be up till midnight every night, keeping the network running.
So since we have a small booth in the dining room, right? Okay. So you're very welcome. If you have any question, we can discuss and we can share. We can talk. Thank you very much. Have a nice day.